Here's my tea. You can probably hear that I'm sick and or ill. How do you say it? What is it? Sick or ill?
Hey, guess who survived?
Thomas! Yeah, happy to see you.
bitluni is now live. Streaming less than a day
See you
radio.
being well. How was your? Are you like
Hi.
living central, like in a big city in Iran, or how have you been? Oh, we can hear TTS. Wait, yeah, sorry. Let me turn on Bluetooth or connect my Bluetooth. It's not connected to my... Ah, now it's connected. Hey TMK. Alright, now I have some tea today in my Hackaday mug. Hey Gerald. Mr. Triad, hello. Hello Dutch, hello Jory. Johnny, where have you been yesterday? Hey Johnny. Hey Life. Hey Appy. 80 Tiny and teaching Claude about who hasn't. Yeah. Hey Jay. Oh, we have some new people today, or at least I don't recognize the names yet. And they are not blue. Most of the people have like moderator rights to post links. Oh yeah. All right. I hope it was tasty. You missed totally Johnny managing two. Oh. Your exams? What exams? Wait, I'm sorry. Yeah. It's just starting, so I'll be ill for some time, probably like a week now. But I hope like the worst will be on the weekend, so we can. Who said what? Yes, yeah, it's a cold or flu, I don't know. I took care of Tony, she caught a cold last week. I took care of her and then she passed it basically to me, which... What, Christian? What did you forget? Hello, by the way. So, Johnny managed to have two levels with -10 par. That's it's not on par, like -10 score on put party. Oh, you have to, yeah. Let me show to the people the screenshot. Oh no. Oh, yeah, forget about it. It won't be a long stream. I will be streaming only for 2 hours today, maybe, because I might need painkillers quite soon. I had only one ibuprofen in the morning, but I had already headache last evening and this morning, so I guess it will be back quite soon. Anyways, yeah, I received something that oh yeah, by the way, guess who also... Judas Priest, what? Is it a song? Yeah, congratulations, Jordy. That's almost as good as the great win that Johnny had yesterday. So we did like try to get this working. We managed. Wait, let me turn it on. At least in some way or form. And then I messed around, and now I can't program them again. So I have like, I don't know, need to like recover to those settings that I had before. Anyways, that wouldn't work properly. Now I found out what the issue was. I show you the issue that we had. Yeah. So Matthew, who basically manages the cluster project, or he manages this past 2 lives. Oh, hey, cool. So yeah, let me give it to the other people who weren't there as well. So Matthew, who manages the site at Altium site, which sponsoring the Ultra cluster, which will be a 2 to the power of 16 MCUs in the cluster configuration. And this was like the first test was basically a double half row of the blades that are these here. That's 32 MCUs. They have all RGB. Oh, I pulled off my power supply. Here we go. Yes. Holy hecker, yeah. If it works, I will make it possible for people to contribute like software. So if you like to hack, to contribute software that we can test run on the Ultra cluster, if it ever works, because not only what was it, Claude can't read data sheets. Also, Gemini Flash can't read data sets. I will tell you that story in a second. Ultra rickroll. Yeah. Certainly ultra rickrolling possible. But I need to make sure that it doesn't break anything. Failure is not an option. Yeah. Basically, what I could do is it's hard to validate software quite easily. So I would need to make sure that you don't access like IOs that you shouldn't access, because in that case you could create shorts and destroy everything. Anyways, hey Arthur, wow, that's the name. I call you 77 from now on. So 767. No. So hello, welcome. Apparently, what I did was the first version. Let me load that project on KiCad. I'm using currently. Sorry, I will show you the file in a second. Uzbekistan. So it's quite late at your. Is it? It is like how many time zones are you from? Central European. What's time at your place? 6-7. Yeah, I did, Thomas. Is it also a meme in Iran? Yeah, you are only from, yeah. Okay, back to KiCad. Here. All right. I thought I will have the main MCU provide the clock that we can use as a clock in for the MCUs here. So here is the clock So clock in, XI here. And since I'm quite familiar with those MCUs, I will show you what I thought. Here. Perfect. We will use this bypass mode as a high-speed clock, high-speed external bypass, which basically turns off the circuitry here and passes basically the external clock to the core. The issue is so we had like problems with making it run last time, and Matthew from Alcium side, he took the project, put it on the Reddit. You can probably find it. I don't know the actual link. Might find it. Let's check if I can get the from the internal chat. There is the. Yeah, simple oscillator, but an oscillator can't drive like 32 at once. I could use an oscillator. I wanted to save on parts because like this double half row will appear 2048 times. So if I add a component of 50 cent to that, even if it's one oscillator, so adding one component of 50 cent is $1,000 already in the whole thing. So I wanted to use a PWM, and that's what we tried. But then I found out with who found it out? I found it out later, maybe. Is it here? Absolute maximum ratings. Maximum of 1.4 volt at the wait, is it the clock? Yeah, clock IO pin. Yeah, Thomas, it would be good to have you here, but there is one issue though. Matthew put it on Reddit, and one Redditor, I will show you. I will show you this screenshot here. What? And I checked. There is no bypass on this MCU. Like the 003 has a bypass mode. Any other one has a bypass mode except for this MCU. So like this family of WCH MCUs don't support external clock. They only support a crystal. What? Yeah, I'm screwed. Yeah, but give me an MCU with multiplication at this cost. You have time until tomorrow. Find me an MCU for 13 cent or 10 to 13 cent, maybe 20 cent, but it is already too much. That will be like 20 cent will be already 12K dollars. So it has to be something that can be purchased within like 10 to 15 cent. Anyways, I built a second one to do some testing, and I didn't connect. Yeah, this project will break my neck. I tell you that. So I didn't connect the clock, and if we connect the power here, I can maybe show it even. It's a perfectly square clock. So attaching it to the I/O pins or to the clock bus is basically killing it. So we can't do it. Yes, I will let it assemble. Most probably JLC. I hope that they will manage to do it. It's quite finicky, and they have some stiff restrictions regarding QFN. So they need like 0.5 millimeter space around QFN, which I ignore. Anyways, we have like a deadline or a time pressure on this project, and I can't get hands on the 595 MCU, which is should be in manufactory like right now, but I can't get hold of it. So I'm keeping this MCU and adding crystals to it. So a crystal is like 2 cents or something, and wouldn't break my neck, but almost 2.5 cents I think it is. Let me show the listing that I got. Hope I can find it. Please don't buy it. Like, you could buy it off and kill my project. Yeah, this is it. Here. Yes. So, lowest price we can get is 2.67 cents. Euro cents, which is 0.3 dollar cents roundabout, maybe even more. That's the range we can save on the passives, because it has like the MCU has an internal matching. Even the reference design doesn't use external like balancing or whatever you call it. Caps. Yeah, and this is the footprint 2 by 1.6 millimeters. Pay up, you mean like yeah, the extended part fee is $3 per assembly. You know how much this board will cost in the end? Like these PCBs without assembly cost $130 because they are impedance matched 6-layer boards. So like paying $6 for extra for 2 components that are not in JC parts is totally like you can completely ignore it. And assembling a whole blade will be like 5 blades is around $2,000 if you assemble it like that. So I need like a better deal to do it later, because yeah, it's quite a lot of cash. Like those fees, that one-time fees for setup on whatever, they're negligible. No, Altium is giving me a budget for that. But the budget is limited, so either we need to scale down from the 65k MCUs to 32k. Or I don't know, need more funding then. Anyways, yeah. Let me not dox myself. It took me 3 days and I had completely to redo the design because beforehand I want the LEDs to line up. Are they lined up? Doesn't look like they're lined up. Wait. Please. Oh, did I move it? Okay, I might need to adjust it a little bit because that looks off. Yeah, that's off. Yeah, I shouldn't change stuff. Anyways, it's so small. So yeah, I think I need to move it by. Yeah, no, I can see already at the grid. Yeah, the difference is 0.5. Yeah, but I have enough space to move it around. I wasn't able actually to keep that here, that ground connection, unfortunately. Which is terrible, but I will be able, after adjusting, get it here. So I will move that away and then we have like some sort of ground connection here. Oop! Here, that's the ground. Here. Ground, 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 and here crystal. Yes, that's the issue. So the cost of each of those units needs to be as little as possible. So I had to redo the design. Beforehand it was all aligned like on top of each other, but now I had the issue that I have a fat crystal that's bigger than the it's almost as big as the MCU. Let's look at this and there's, by the way, this is Altium, so oh yeah, this will be the whole board, the blade size wise. So that is dialed in. This is like a column controller. This is the row controller. These are the rows, and oh yeah, it's highlighted. I don't know how the 3D mode works, but look at the crystal. I needed to make space for that, and I wasn't able to route like two wires to the other side to have basically a mirror image on the upper row, and I want the LEDs and everything to line up. But look at that. I rotated it instead of mirroring it now, and everything is shifted, but I can take this whole board now and easily rotate it. I don't need to rewire anything, and that's why I had to change all the design. It took me like ages to rewire everything, and I'm not done yet fully. I think everything is connected, but if you look closely, there are issues. I can show you like. Okay, let me go to the top layer. Hey Sonic! If you look closely, I have, especially in the beginning of the board, like I need like a ground connection here, so a via must fit somehow. I'll probably move that away and put a via somewhere here, because this is a strip line. This here is a specified failure rate. I have no clue. I'm not using they're using like internal capacitance of the MCU. Like the reference design, show you that. Here. Reference design doesn't even have capacitors here. It's like free from capacitors because it has internal matching. It is like matched for I think 8 picofarads plus the traces that you got, and that's why I get like 12 picofarad. Where is the failure rate? Is it mentioned anywhere in the datasheet? It doesn't look like there is anything. I mean, I will either rework. As long as I have like 64K MCUs that are working, we can render QVGA image. The other like 1536 MCUs are spares. So we have like more. No, it's not. So we can fail like 1.5% failure. We can compensate for, and then after that I need to, I don't know, think like rework it. At least every MCU has an LED, and we can basically see which one doesn't work in the end. So yeah, this is this rework, and then what I didn't consider on these boards here is the vertical routing for the columns, and I need like 16 CS lines here, so these are the 16 lines. Let me switch the layer. Yeah, Alcim is sponsoring, and I don't think I will be able to make this board in KiCad. Especially like I have impedance routing and everything here. I'm really the difference is quite big. I would love to do it in KiCad, but then someone else needs to give me $15,000 to do so. For the project, for the parts. Okay, so that will be the cost. Anyways, there's like this is slightly better routed because we have like flyby bus here, Miso Mosi STK, and this will go like this will repeat boop, 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 like that. So this is still quite tight. I need a little bit more space. There is not a single ground here. Here comes the money. That's the truth. They're supporting it, and I wouldn't do this project if they wouldn't support it. So I can only do so much. If like letting one of those PCBs assemble, or 5 of those PCBs is already like $2,000. Do you think I would ever spend that from my pocket? For okay, I spent already thousands of dollars for a single project from my pocket, but it doesn't happen quite often, especially if I want to make it like scale it like that. Anyways, or do you want me to embezzle the excavator fund money? I can still like push around stuff here, so like move the sponsorship deal. I always need to check that there is like still ground connection, because this is like a strip line. I don't know if you can see that. It's a quite I don't know if it's like good or bad or whatever I did there. Basically, if you see that, um, we have all those wires. Yes, it is 6 layers. That's why it's so expensive. So the issue here, okay, this is the backplane isn't ground anyway, so we can ignore that. No, where's this? That wasn't the ground plane. Here, there is not a single antenna here. Look at that. It's always like wrapping around. So this is ground, and all the traces are impedance matched for a strip line design. So they have like an odd width of 0.116 millimeters in that case on this layer. There is one one ground layer on top of it or on the bottom of it, and then there is the other signal layer. But the funny thing here is I interlaced it, the design, so we have like the ground from the other layer being basically adjacent or on top or on bottom of the traces. So it's like, you see, like interleaved. So we have ground from all directions on the same plane, on one plane which is complete ground, and on the other side, like the other signal layer has basically that. So that's quite interesting. This is like here, this is as dense as I liked it to do. You see, this is ground. This is basically return path. Dummy likes that. That's I like that approval. And this layer is here. So we have always a return path in all directions and basically shielding and whatever. So no crosstalk. Hopefully there is ground everywhere. The only way would be like diagonally, but the ground is closer. The orthogonal ground is always closer than the diagonal. So that should be all right, at least in that case. And this design is already like that, and we could test what's the fastest we can communicate with this kind of bus. Same on this year. And this in the center, the SPI is even more sound. I mean, all the vias might be disturbing, but there is nothing in between here, and we need just to access the bus. Okay, this is more or less like a stub. Some stubs, but they're like less than 1 centimeter, and we don't go in gigahertz range. So I hope this is like we can measure it. The longest stub, let me check that. That connection, you can see that directly here, is selected is 21 picoseconds. So we are totally fine. If there is a reflection or anything. Yeah, but you know what? I thought about it, Thomas. First and second from the bottom, from top and bottom. Why would it improve it? Because you have air on top of it. The issue is the signal. I don't. The copper on the inner layers is half as thick as on the top and bottom layers, and I wanted to sandwich everything into pre-preg. Oh, okay. Yeah, I see that. That's one advantage. The other issue is, imagine that like I have everything sandwiched now, like the longest signal path is sandwiched between the ground planes, and look what I have here: oscillator, oscillator. That's 22 megahertz crystals everywhere. So I mean, you could put it on the bottom, but on the bottom we have like this. The arrangement of the supercluster is the boards are like the closest side. They are only like few millimeters apart. So we have some radiation going on there. That will be a quite noisy environment, especially with PWMing the LEDs like we do here on that one. You can see that's like fading. So there is a lot of noise going on. This side is very noisy, and on the bottom there would be like the next board, which is basically adjacent to it. It will look like that. It's weird because like you can see a lot of that PCB, but from the side then. But oh well, it is what it is. We can populate it less dense, but the full build will be quite dense. So there is noise from everywhere. Because SIG and ground in that case would be closer. Okay, let me check the stack up. Layer stack manager. Okay, yeah. Certainly. Look at that. The distance between this copper and this copper. Okay, this is my whatever SIG ground SIG. Okay, so for you would be whatever signal ground signal. Okay, and then whatever. Yeah. The other stack ups are way more expensive. We could like do different stack ups where we don't have like this thick layer between the ground plane and that. So actually the opposing copper of the two signal layers is the closest here. Fat Thursday. But look at this. The thickness is thicker than the distance. Pączki. Oh, I need to tell this Tony. She loves pączki, so she will bring some. The Shipu. Welcome, by the way. I didn't notice. I'm just listening to the chat, but I didn't know it was you. So I have like a clearance to the ground next to the copper is 0.1 millimeters, and already like the thickness, the thinnest thickness. Okay, here it is, but I have protection. This is basically ground. It will be good enough. I needed it 6 layers for that, otherwise I wouldn't be able to like protect it from destroying itself with noise. Yeah, so what I did here is, if you see, we have like this the SPI, and then we have the ground, the return path on the left side and right side from that, or whichever, top or bottom. And then if we go to the top layer, let me turn that off. The top layer, the grounds connect here, and basically the strip line continues. Hey Chris. So these were my thoughts, but you can see there are issues like this here. I will probably need to address that. So add another king here. Yeah, that's good enough. Like add another king so I have enough clearance. But this is like fine tuning. Uh-oh. Yeah, it will be barely spaced here. Hey Jesse Harry, look at that. Beautiful. This is what I like to see. I'm not sure if this is good. Anyways, yeah, this is the new design. It's staggered. The JC code is, let me check that. Do I have it selected? Wait, there's like impedance matching here. Maybe that. Okay, the document is not here. I can find it out for you. Okay. Here. Okay, so wait. Where's the calculator? That's 4 layer, no, 1.6. This is the one, I think. Does it say the code? Oh, no requirement. Wait, here, this is the requirement. I think that it's the cheapest one. The other ones are quite a markup. I think it's that one, yeah. That rings a bell. You can check my order list. Docs me. Oh, come on. Yeah. That's the stack up. I'll post it here. So that is that. It's basically the cheapest with impedance matching. I don't know if it's you can get like a way better stack up where the layers that I like to use are the closest together, but like the ground planes and the signal layers. But oh well, the costs are exploding already. Anyways, yeah, I need to clean that up a little bit, find like the stubs here, resolve here. I'm thinking of at least adding a footprint for testing to the main MCU, because when we used it, we were not able to run it faster than 120 megahertz with the internal oscillator. So I moved it up a little bit, and there is enough space for the crystal that we need here, which is 8 megahertz, and they are not available in the smaller size here. At least I wasn't able to find one. Or I'm stupid. Wait, maybe I'm stupid. Let me check that. Oh wait, let's go here, crystal. Magnetic. Now we'll CNC everything. SMD 2016 4 pins. Let's check that. 4 pins. These are the ones that we want. We want also 8 megahertz for the main MCU. Oh. Eh? What did I miss? Also in stock. There are only 9 options. Why are they so expensive? Yeah. 25. $25.20. Let's check that. What else do we have? SMD. Why are they so expensive? Am I stupid? 32.25. Here we go. You know how big that is? 3 millimeters. So these are the ones that we can take. 32 by 25. Now let's get here. This is the space we get. This is okay, this is 3, 4. So we barely have space for the crystal here. And we need also like the capacitors. This is like in one you underestimate how small this is. The space. It's a huge crystal. Alright, so I know which one I need to take, which size. That would fit quite okay, I must admit. Wait, no, the board ends here. Here, this is where the board ends. So the board ends here, and this is the width, and yeah, we need some clearance. So I mean, we can move it up a little bit. We need also like the ground, and 32 will be this. So this is basically the size, the footprint for that. I also need like to add, I don't know where, but I still need to fit grounds somewhere here. I have some space here, but this is basically the board edge. I really don't want to put a lot of here. Not sure how big it can be in the end. Alright, so that's that project. The current state. I have to finish it and order it before Chinese New Year. Anyone knows when JLC closes down? They don't post it on. They didn't post it at least. Spring Festival holiday special. Okay, here we go. Here. Arrange production, factory, delivery, holidays. So here this week is nothing. Holiday, 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 Sunday, arrange shipment. Okay. That means basically they're working. Customer service was working like. Yeah, but this start before. And Europacket, it needs to be finished in February. So if I order boards, the test board and then an assembled version, I mean an assembled version could be also produced here, so I have enough time. I need really to dial it in to make it work. If it doesn't work, I'm screwed. Especially we don't have like the column. Testing the column here, the communication, which is a way longer one, will be also quite crucial. So this needs to be really dialed in. I would order like a second one that has basically this part here separately, which is a quite long board, 25 centimeters. That will be pricey. And it doesn't even blink because that doesn't have an LED planned in. Maybe I add it tomorrow. It would be good to see if it's working or not. Anyways, yeah, I'm quite limited regarding the production here. So I guess if I order my PCB, yeah, I need to order this week so it gets shipped. I can review it in the beginning of February, adjust the design, order it, and then see what happens. Like if it's getting produced here. Test connector. Where is it from? JLC or LCC? Here we go. Oh, is it a magnetic? No. You know what? How we tested? You missed that maybe. Did you watch it? Or did I show it? Look at that. They are pointy. So this is the way we programmed. Where is it? Huh? Here. How we programmed those MCUs. On the back, programming pins, and basically, choop. And this will be put on a 3D printer, CNC, whatever, and then I can program them one by one. At least. Yeah, I thought about it because my old designs I program all at once, but this is not recommended to do. That was always a problem with all my clusters, and in this case I wanted to be able to program them individually. In this version I'm using only 2 pads. In the newer version I added the clock because we have one wire debugging interface, but the 2 wire we had like issues programming last time, and now I'm also exposing the clock, so we can use 2 wire debugging here just to be sure for stability. This is basically it. Yeah, so if I have like one, I can do what I would do is basically write G codes. You can easily do that over serial to any 3D printer. Put the probe, the pogo probe, on the tip, like on the head of the printer or CNC, whatever you like. Like any CNC or good printer supports G codes, and then I can that's why they're all well spaced. This is like the main MCU, so this one here, I'm not sure if I leave it there, but these are the ones I can basically calculate exactly the position, and I can upload a firmware individually and maybe even give each of those with the user bytes their physical address on this whole array. So we can test it this way, debug it or whatever. Or I do like a lot of pogo pins. I mean, I have a gazillion of... Where's my assortment? I bought it once of... Oh really? Bumble Lab can do MQTT control, that's cool. Here. I have plenty, I can do like multiplexing of a complete row or something, so look at that. I have plenty of different pogo pins and I can just take those that are most suitable for that case. I have like round ones and pointy ones, but I like the pointy ones the most. Alright, so that was the project update on that one. And who was the person that... Yeah, maybe it would be easier. I guess what I will do, I will just upload a bootloader that has to work so we can flash it remotely and debug remotely or whatever. So basically a core software that's flashed on that can do reflash again. Yeah. You know what? I opened it. And I thought I was scammed because there was nothing in except for this here. How tiny is that? Look at the connector density. Yeah, 65,000 times, so the printer will die before I'm done. This is small, isn't it? Here, I thought, where's my other Tang? I have the other ones. I thought this board is huge, but look at this. This is tiny. Yeah, that's basically a stamp. The primer dog, I got that. The soldering looks really... They didn't use a lot of... Yeah, so that, and I got also the SDRAM module. Now how you plug it in, probably like that. Yeah. Oh shit, I can't get it off anymore. Does it make contact with the USB connector? A classic RAM's board had also the issue that it shorted with the USB connector. Turn on the camera so we can play together. Yeah, my voice is already quite damaged. I can't talk for too long today, and you see like tantrums here. Plateau of connectors? What does that mean? Wait. Here. Oh yeah, the pinnacle of connectors. The small thinking. This is quite stiff. Can't get it off anymore. Will break. My fingernails. What? DE Nano. What? Yeah, it looks like. Almost out. Oh. we can put quite a lot of things on there. Alright, so what I thought is this board doesn't expose it properly, like the stuff. We have like the PMODs here and extras here, but the GPIOs, what we found out last time, there are plenty of GPIOs, and what I thought is, let's use it to digest the data from the blade. So we will put basically 32 of those. Oh wait, that's expensive. That's $1,000. Okay, maybe we can digest data from 4 blades. Let me check that. How expensive was this thing? That's pricey though. We need to digest data. I didn't plug it in yet, so we need to. We can. I don't know if there's something on there. The software dev. I will be. If I can do something, then it's software, not the hardware. The hardware, okay, it showed up as something. Wait, I don't see a drive. NASA? Why? Hardware is a hobby, software is a job. Let's say it's my profession. Oh, it was like 20 years ago now. I stopped I stopped 6 years ago working professionally. Only coding stuff. No, it's not. Divide and conquer. It's just a pyramid scheme. The issue is like the bottleneck. We start to get a bandwidth bottleneck at some point. That's why this is already the 4th level. We have, if you look at that here, level 0. No. Top layer here, MCU level 0, level 1, so there will be more. Like I did only like, this is for the parts for 4 of those modules. I wrote even a script that distributes it. Wait, let me check. If this will work. Wait, it's a Delphi. I never used Delphi. I mean, I used Turbo Pascal in the 90s. That's quite a long time. You can do Delphi scripting, also JS, but I'm not sure. Let's run a script on the board. Move multi-channels. 0. 16 is basically the next row. BA, B1A. Yeah. Let's see. Hey Casper, my tea is gone. Finished moving 32 channels. Now nothing happened. Yeah, the script not working. It worked on the other thing. Oh no, I deleted it. I think I deleted the row beneath it. Yeah. Wait. Or no, it's not there. Yeah. Anyways, the scripting is quite tough, and I did a lot of wrestling with Gemini to finish that because yeah, most of it worked, but quite a lot of interfacing didn't work at all. Anyways, this seems not to work with my newest board. I need to check if I started rewriting it or whatever this is. Move channel. Yeah. Okay. Yeah, Casper. Here we go. FPGA time. Oh! It even says this faces downwards. So they made it clear. I want to see what it appeared as. Um, oh no. What is the USB log view? Okay. What intro? What? Here we go. USB composite serial converter A and serial converter B. Interesting. So I know. That's like the typical the programming interface. I remember that was like yeah. One is for debugging, JTAG, and the other one is programming. Is it? Yeah, that's not. Oh, it responded. GGG. It's echoing. Yeah, baud rate can be ignored on CDC. USB baud rate you can completely ignore. That's just for legacy stuff. Or compatibility. Yeah. CDC. Let's see what Gemini says. Or ignored. It's basically it's just if you configure that, you can physically do whatever. If it's a translator, like basically an interface between USB and serial. On the other side, you could use that rate to change whatever setting. Yeah, so Gemini was hallucinating. Quote in here. Gemini was hallucinating when I tried to. We can find that. Maybe I can. I have the history. Unexpected. Oh no. I'm hungry. This is still running. I'm hungry. All of the sudden, let me get some bread. I'll be back in a second. How can I be so hungry that I can't concentrate anymore? Who is in Hungary? Orban, Viktor Orban is in Hungary. Here. You enjoy the lights? I'll be back in a second. I'm back. Okay. This is what we get. Bread with Tilsiter cheese and some rucola and olives. This will be this is what we going to eat. Professional YouTuber, perfect focus, yeah. This one, yeah. Yes, I'm an olive fanatic, even though they're like the cheapest olives you can get, the green ones. But the dark ones, there are only colored green ones, so not worth buying anything else than these either, or you like buy actually fermented ones. So, what can we do with that? The connectors grows. Let's turn on the microscope and take a look at it. In beer? What? Never heard olives with beer. Thermal can. Yeah, it's quite cold. Oh, you know what? Since I'm living here for 3 years almost, I didn't experience a winter like that. We are completely snowed in. Even the plowman fails to clean the road. There we go. I don't know, it's dark outside, so I can probably show. Yeah, no, you won't be seeing anything. Maybe. Let me check if I can. We have so many reflections from the. Nah, I can't reach. Everything is entangled, a lot of cables. Nah, the only reflections. Yeah. Alright, let's take a look at the module a little bit. What's the connector voltage here? This is crazy. You zoom in. What kind of connector is that? Oh yeah, it's buried in the snow. What are those? They look like they are a little bit fried. I have no clue. I never held a computer module in my hand. Ah. Ferrite beads, okay. Not much going on this side. And then we have also here length matched traces. I don't know if you can see that. Yeah. You can see dual flat pack. 50 megahertz. Two voltages. So you think it's step down converters? Probably the voltage is adjusted with the resistors here. You're right, we can put this in a watch. $17 by 23. Cool. Yeah. But then you need to consider that stepping down to 1.1 volts, you have to burn two-thirds of the current. So if this little thing draws like 1 amp, okay, maybe 300 milliamps or whatever, you are in trouble trying to get the heat off this. We can find out. I bought one of those recommended units so we can see how much current it draws. But it's not doing much right now. Okay, 50 milliamps. Yeah. KBC. You mean one of the ICs on the back? Does it have a KBC marking? Yeah. Need to zoom in. Oh. Yeah. Yeah, it's DC to DC. It probably generates like the two voltages that we need. Let's take a look. Look. I'm full of olives, I'm sorry. Gotcha. Wait, this is the wrong one. Here. Okay. Oh, the olives are good. I need more olives. I can eat a jar of olives in one go. I don't know why. I love the bitterness. Oh no, there are only 3 olives left. But I can buy more. You monster! What did you find there? Okay, now I need to check what you saw there. No, nothing compromising. Where did you find it? I can see it. Huh? Or was it in? I don't know where you found it. Yeah. If you rewatch like a few streams back, I repaired repaired my Ford Focus instruments board. It had like some severe corrosion, and it wouldn't work anymore. It was rebooting and stuff, and now it's working again. But some of the LEDs are not working anymore. So I don't know. We have some 250 kilobytes of SRAM. Plus distributed. Wait. That's the total, is it? Let's find out. Yeah, it's 18 kilobits each. How does DSPs work on FPGAs? Also, we have 6 PLLs, that's cool. 1 gigabits per second LVDS. So can we do Ethernet then? Like 1 gigabit Ethernet. Maybe DeFi hardcore. Rohan. Ah, okay. Yeah, that's what we measured. Okay, but how do they say? I mean, this is pin 1, pin 959, but what's the other ones? Like, does it go round robin? Or does it go here? Hey, Magic Gumbo! Fondue cam? Aww. Fondue. I have fondue in my fridge, but not today because I'm sick. I'll be not streaming for long today, and I didn't want like to set up the fondue. But next week, probably I will still have a running nose, so I won't be smelling the cheese for several consecutive days afterwards in my lab and in front of my computer, because that's quite often an issue here, that it's quite smelly. Okay, we checked, but how many 8-bit pairs can we process here? That's alright, that's alright. Your nose ran away last week. Are you feeling well again? Voltage bank. I just need like a complete explanation of like okay, schematic. Oh, the schematic is good. Doc, here we go. Nice. There we got it here. $51. Let me copy that. Let's go to Altium. Let's see if we can find it. Nope. Okay, minus the... Nope. Can't find it here. Let me find it here. Hyros connector. It's $1 each. So it's $2 for the connector. It's alright if it's good. Oh, wait a second. Yeah, where's Andy? Is there anything new about the analog ray tracer? Should we? Ah, the post-it fell off my. It's not. I need to put. Yeah, I will use some Kapton tape to fixate it there, so I won't forget about this project. So Thomas, you are very knowledgeable. Maybe you have some ideas to do that. I forgot all the thoughts that we had on that last time. I think we tried to narrow down, or was it last time or the time before, try to narrow it down what we actually need, like the least hey Gwindor. Gwindor, since you're the LED guy, did you see that already last? Have you been there last time? Wait, wrong one. Here, this one. Yeah, I don't know. Yeah, I've been there last time. Oh, yeah, that's 16-bit PWM, but it has some issues. Especially that one reboots after a second. Instead of what? Tea instead of coffee? What? He doesn't drink coffee, he drinks always tea. But my tea is empty already. There is still like the tea bag inside. Oh, you can see that. AZ80, no, that's the sub-assembly of the ultra cluster. You see the white line? That's the outline of the part that will basically repeat for 32 times. Who has coffee? You drinking coffee in the evening? I thought only people like me can do that and then sleep well all night. Alright, so the connectors are model. They're like 75 cents if you. Yeah, ADHD is the issue, huh? Okay, let's continue. Schematic. Let's see. What is this? Oh, wait. Yeah, that's the dock. Because there is like the pin connector and the USB. Oh, what happened on my... Oh no, I wasn't able to read. You wrote just before I I needed to take a shower before the stream because I was really greasy and gross. That's why I wasn't able to read your messages yet, but I noticed them. No, don't worry, I will read them maybe today evening or tomorrow. I'm feeling worse and worse. Greasy, yeah. Yeah, it's really like my hair. Since I'm sick now, I try not to shower at all. I just cover my fat hair underneath the head, so I don't. Okay, that's the flash. So other people don't see me when I'm outside. What is this? Oh, that's basically a part of the FPGA. It's a multi-part schematic like that. Oh wow. Okay, that is what I want. I want the list of the actual GPIOs. Here we go. We have 1.8 volts. We get 5 volts in. So this is quite interesting. We must be such nerds that we enjoy looking at schematics. There's different voltage ins, or is it just to handle a lot of... Yeah, I guess it's just for the current, because you have current limits on each pins. It might be on, but this is the core board. They gained a lot with 4K. Who what? Oh yeah, 3 different voltages here. 1.8, 3.3, 2.5. But what are those? 1.2 volts. Oh yeah, that's true. 0.9. We have 6 different voltages. We have 5 volts, 1.8, 3.3, 2.5, 1.2, and 0.9. Wow. This is madness. But they give us everything here. This is, I like this open design. Does it say copyright or anything? Yeah, that must be fast, huh? Yeah. Okay, let's take a look at the IOs here. So this is power handling. This is IO 6. Different banks. Are they all different powers? Already, yeah, probably. Flash SPI. Okay, so this is used for flash. So basically bank 4 is gone. But I'm wondering why... Okay, this is LVDS. This is all... Why is it split like that? It's weird. MIPI bank. MIPI is that video interface? Mobile Industry Processor Interface. High-speed interface for image sensors to send video still images to processors supporting 8K resolutions. It's basically for camera. Differential pairs, yeah, AB here. You can see that AB, AB, AB. That's all differential pairs. But if we if we want to digest, I need to find out if we get like an 8-bit parallel interface, in how many blades would we be able to basically process with one of those devices. So one blade has like 2 column controllers, left and right, which will be then 16 in total. So we have 16 lines for one blade, which looks like, I don't know if we can combine the banks. Probably we can in some way or form. Not sure what the limitations are. Maybe we should check the data sheet. But yeah, I remember that company. You need like to. Oh wait, you can get this on Mauser. Maybe there is. Foo. Can I get the datasheet there now? Oh yeah, I can. Here. HDL header? Yeah, probably. I/O buffer, so I/O input blocks. Buffer pair. Support multiple I/O standards, including differential single-ended multiple levels. Bank distribution. Each bank has independent I/O power supply. Oh yes, it's so good. Okay, differential pairs here, P. Standard, they work on that. Yeah, the issue is probably just a physical limitation. Not sure, like this connector, if I like to use that one, has a limitation on what I can do. Maybe I need to take PCI Express connectors, but PCI Express connectors are too wide. This is like 1 centimeter wide, and I need like an edge board connector that yeah, is fast enough. So basically we go as fast as possible. Yeah, more or less. It's not an ISA connector because it doesn't has the key. I just bought them for a different project and never used them. So I have enough of those connectors in stock in different lengths. So different pin counts as well, 40 times 2. The pins required is not many. Like we have 2 times 8 for the downstream or upstream bus. Then we need the clocks, some SPI communication times 2. So basically, I would say in total for managing everything on the blade, there will be like maybe 24 to 32, maybe 32 IOs, and the rest will be filled up with power. So my design is like that because we don't have don't draw a lot of power. It will be I think 60 watts per panel maximum. What will be possible, but I don't think we will use that much power. 60 watt will be, can we calculate how much power do we need? Uh, 10 milliamps will be a core. Yeah, 10 amps times 2.7 maybe. So it's 30 watts alone on the MCUs, roundabout. Maybe a little bit more if we run it at a higher voltage. But then you have also the LEDs, and the LEDs are like 3 milliamps per LED. So that's also substantial, is it? Another 10 watts. So we have like 40 watts. So probably not many. And the power design, look at that. I put, since we have like thick copper on the front and the back, and I mentioned it before, on the back I have let me turn off the front layers here. Backplane connectors. Yeah, but then you need like to align them properly. How do you do that with an edge? I don't know. I can use like some sort of PCI Express thing. Yeah, so look at that. I just put on the back side, since we have 2 ground planes, there are no worries. What software? That's the VCC for the core. That's all the only connection here, 10 milliamps. But we can see this one here supports up to 0.761 amps, because yeah, it is like 0.02 ohms. A VIA seems to be good enough for the power here, but we have a few more vias for the ground, because it's also the source for the LEDs. So we have 3 milliamps for the LEDs, so we have a little bit more ground. Yeah, we are limited basically by the wall power, which is like 16 amps, and that's what we calculated. We probably won't need like 3 kilowatts, but it's basically a 3 or 2 kilowatt heater in the end if it's fully populated. Yeah, so this is the design. Basically, this is the LED power. It's applied like that. You can see there are like some bottlenecks, but it's still like super wide. Like we have like a width on yeah, half a millimeter here is a bottleneck for the current. That's plenty. I'm not sure if we can calculate the resistance here. So it has 32 times the power lane for LEDs and 32 times the power for that. And we can basically, if we use a connector like that, we can basically in the center like leave like pair of pins just for the power of each column, and we could actually control the individual columns, but yeah, we get some parasitic power flow, and then we have some negative voltage, so I really don't want to. Yes, power regulation on the board, yes, but I have the issue that if that is messed up and breaks or whatever, then I have no way of reworking. This is like the most expensive part of the whole device. So if we populate and then our power thing doesn't work properly, what happens then? We can't rework. We need like to bodge it to the connector. Yeah, it's not happening. So I guess I will an option. Yeah, we can basically from anything that happens like on the baseboard or the power board that's somewhere like where this is connected to. So this is the upside. Here will be the connector, like the edge board or here. We could make this longer. It's not a problem. And put some switching here to adjust also the voltages and whatnot. But I didn't want to overcomplicate it. I would rather put that all on pins, and then I can still mess around with the main board. If I see, yeah, power regulation isn't that great, then I can still improve it there. But I can't do another round of those PCBs. Each round cost me several thousand, because like you have a order limit and setup cost and whatnot. Yes, bypass would be an option basically. So what I can imagine doing is basically adding the power supply design to the board, not populating it. Yeah, invoice in PDF. So the crystal revision I will be ordering probably this week. Maybe on the weekend I will. It's not finished yet. It has like we saw before, sometimes the ground return path is disconnected to some side or whatever. I like to make this side more dense, so I have enough more space on. Show it to me. More space for the bus. That's the ground. Okay. So it's quite dense. There is no ground whatsoever, and if I put a ground via here, that wouldn't work. Look at that ground. Yeah, that's not working. Wait, let me move. Tracks. Wait, selection components here. Yeah, this is, and we are already off. Like the actual, I think it needs to be here. Yeah, and I don't want the kings here, so I might leave the kings in there because yeah, because then I can like fly by and connect it here. We don't have like any stops if we do it here, but every time I do that I need to connect also the return path, so there need to be like grounds which are close to that somehow. And since this is already the other board, so this is this side, if we like repeat it, then there is not much on this side. There is no space whatsoever, so this will go like maybe around like that. Actually root is, oh damn it, like that. Oh, wrong layer. But yeah, so one at a time. There needs like to be. Hey DFGA, next revision of this board here. Wait a second. Looks like Rat's Nest. Did my script work after all? Let me close that. It's a weird thing that script might not update something. There is like a database. DFGA, we made already like one test. Oh yeah, look at that. Yes, it is. It worked. Okay, so my script worked, but it didn't update for some reason. It's so weird. Yeah, but basically the script is able to copy that, and then I can probably do it also with the traces. I mean, I'm using rooms, which is basically a structure that repeats. So this is a room here, and we can just copy everything from one room to the other. So like this one, this is basically the room of the row cluster, and we could copy. Let me show it to you. Rooms. Duke, yeah, the composite is finished and I need to edit it. I have even a script, but I didn't record it. I didn't cut it because I'm on the crunch here. I need to order stuff before Chinese New Year, and basically this is priority now. Okay, so I can copy that design to this one, and then I can select what I want to copy here. Copy rooted nets, copy all objects touching the room, exclude no net, enclosed and touching objects. We can do only touching or enclosed and touching, and if we run it like that, here we go. Oh yeah, you can see the orientation. It's a different orientation. Wait, let me revert that. No, I didn't see that KiCad can do this. And I love it because I was able like to copy basically I designed not the first one. First one is like a little bit odd because of that. I designed this one and then basically copied it. Oh, dip trace. Sonic, it's so funny that you use dip trace. So cool. Design rooms, copy room format, and I will. Oops, wrong room. Here, and copy room orientation. So now it will be the right way around. Okay, you can see I messed up everything, but oh, scripting with Turbo Pascal, maybe, you know what maybe happened? I can imagine that basically the people who did dip trace or whatever were switching sides or other way around. But I guess since dip trace was quite long, yeah, but it's cool. Here we go, Turbo Pascal, yeah, Delphi basically. I hate it that you need to define all the variables in the beginning. No, these are CH32V303. $1,000 per year. They are lowering, I think, now the version. The learning curve is quite steep. There are dozens of features and plenty of things that you can do a different way. Yeah, $1,000 per year is yeah, basically $100 or whatever. What? C99? What are you talking about? What you talking? No, Turbo Pascal basically is the Delphi is the object-oriented version of Turbo Pascal. I guess. I don't know. Have you tried Google Anti-Gravity? I tried the cross-compile OpenCV and what is a silicone chip? Oh, silicone. Google Anti-Gravity. I asked Gemini if you use like Gemini, you need to be sure that you use the thinking model instead of okay. So I don't know if it's fixed itself. Ah! Interesting. Last time it was convinced it is like 24 or 16 megahertz crystal, but it only supports 22 megahertz. It was I told it no, it's 32 megahertz, and then it was convinced. It tried to convince me that it's not 32 megahertz. And then I clicked and switched to thinking and said, your information is wrong, try again. And then it found out it is 32 megahertz. And since then it seems it adjusted, but it's weird. It was like really convinced the wrong frequency there. Yeah, I corrected it. You do it all the time? Yeah. So it was basically me, but it was like really convinced. I told no, it's 32 megahertz, and it was still convinced until I switched to the thinking model and told it try again. Oh, now my throat hurts. I'm aggravated about hallucinating AIs. Yeah. So peeps, unfortunately, I'm not able like to stream a lot. I'm getting headache and my throat is killing me already. It was really fun talking with you, checking things. I hope I can show you some more progress next time. So I will just This is funny. Did I save it? No, I think I pushed it because there's like version control is built in. Yeah. I hope I'm good next Wednesday so we can stream. Let me check that. Refill. Yeah. Just wanted to see that there is enough space for the ground here. C99. Yeah, but that's I'm not sure what you're trying to talk about right now. We were talking about Pascal and Delphi. Anyways, yeah, one thing I wasn't able to do, like pointy edges, even though I have like a design, maybe someone has a solution for that. I needed, yeah, here. I even designed a rule for the footprint, so it uses a diagonal here, but it doesn't like the pointy ones here. If there is not enough space so it can flood around it, it won't do it. So I added like spikes. The spikes are connecting. Ah. No, they are sponsoring it. So they are paying for this ultra cluster. You missed that part since you came later. They are basically paying for that ultra cluster with 65,000 cores, 2 to the power of 16 core ultra cluster. Did I? Yeah, let me show it again. The plan right now. Ah, wait. No. When I order that, it will take 8 days. Last time it was 8 days for them to manufacture, or I do a quick order, but I don't believe that is possible. Here. So here, this part here, this is the part here, you see that? This is like, here, this is the blades, and these are like SPI, a hybrid form of SPI and parallel bus. But yeah, since we have like a clock chip select for each of the MCUs, they can use it for serial upstream simultaneously. So if the MCU here switches like to this simultaneous simultaneous communication, it will just send a clock on SPI and commands, and they will basically signal out on the CS line. They will take control of the CS line and signal out. Let's give it, the code name is neck breaker right now. It will break my neck. And I put this, that's why we have like this odd wiring here. I put them on two 16-bit registers so I can store the data really fast with only like 2 to 3 cycles in the SRAM that we are receiving, and then process and upstream to to the core, to the another level. But that's the same speed as the single one from here, but these are clocked a little bit slower. So yeah, the actual bottleneck will be, then we have like the column controller, which is here, and there will be another column controller here, and these are the clusters here, and this is where This is how we need to fit. Look at that. This is the this is the space we are working with. Also the PCB. Look how tight it is. I have only like 2 millimeters. There's like, I think the tolerance of the manufacturer's tolerance for this container is 1 millimeter. So I left like 2 millimeter space here. So we have some sort of still flow. And then if I enable that, look how dense this is. That's why I don't like any surface level. Nope, because there are, this is the size limit that I have. That's why that's why everything is so cramped, because yeah, I can't put like another centimeter here. Already like this is already some leeway that I have with that here. At some point there would be touching. Of course, like if you look at that, I put in even like the actual size of the MCUs, so they are one-sided. Yeah, we can't put a lot more there. This is basically how much physically we can fit. 10 cents, but this is not the CH32V3. It's the CH570. It's also similar price. Yeah, ultra cluster basically, because we have the mega cluster. Ultra cluster is still, yeah, this is basically more or less. I don't know if this way around. Probably if it's not liquid cooled, then if it's air cooled, then it's this way around. So otherwise, and it will be easier because we don't need like to mount this just with friction in the connectors here. And there will be a lot of PCBs inside here, whatever. We can put whatever here. This is only one board each. We can get several Yes. Yeah. Yeah, well discovered. That's a lot of stuff. Yeah, I'm an expert now. I'm using Alcium Design. Probably a cringy way, but even like for copying the layouts. Yes, of course. Well, it is 3 kilowatts. 3 kilowatts in a closed compartment, and I don't want to have it open. Cool. Yeah, mineral oil has the issue that it degrades and it gets murky. And the other coolants, like submerged coolants that are certified for the PCBs, because like imagine that this is like 15K for this whole assembly. If the coolant that we put it in dissolves the PCBs and breaks them, and we have like 15K damage. So there are some certified submerged cooling certified liquids, but they are all PFAS and discontinued. Puts it in the fridge. Yeah, but the fridge needs to cool with not 200 watts like a regular fridge. Oh no, what is the maximum cooling power of a fridge? It's quite low. This is like 3 kilowatts in the end. Up to. It depends how bright we want the LEDs, because that's quite bright. Yes, that's the solution that I want to put it like here. Here in the middle, intake, and then little hose at the end here. And hope it will circulate like that. I don't know. Or if there is enough space here, it will go like that and distribute like that. Stratosphere for cooling. Yeah, we will see. If we leave it open, then it won't overheat too much. Yeah, but I don't use the radio on the CH570. It is quite capable because it's 100 megahertz and has like multiplication compared to the V003. Yeah, this is the dream, people, but it's driving me nuts because we need to put a crystal that costs us like another 2K for that. Yeah, but look at that. You have like always the air will flow the path of the least resistance. So it will go, the majority of the air will go like that. And Sonic, you missed that part. The CH570 doesn't support like external clocks. I totally messed that up. I don't know why I assumed, because like every single of the other MCUs from WCH support that, but not this one. So I can show you. Oh no, doesn't have a year. Bypass mode. Bypass mode. And this is what I wanted to use, but that one doesn't have bypass mode. Oh wait, yeah. If we do clock or crystal. Yeah, so that's basically it. We can forget it. It's too sensitive. I need to go safe. That's what I discussed with the team. I will just put the crystal. That's why I have now the second iteration. And this is, I'm repeating myself, but yeah, you weren't here before. So this is, what's rotation? Here. This is the second iteration. And we need a lot of crystals. I needed a complete redesign, and also it's staggered now because otherwise I wasn't able to fit it. Yeah, it will hum. Yeah, I hope that they won't be like, they will not start up at the same time. So we will have like 32 megahertz, which is shifted, so it will be a generic noise and it will cancel out. It is like net zero. Or will it resonate? It will send like, what radio frequency? Yeah, but the power they. Radio spectrum. Okay, let's see. Kilohertz. Very high. FM broadcast, television broadcast, cable television broadcast. Oh shit. Okay, we need to start it in a Faraday cage. Otherwise, we might get arrested for disturbing like police and fire emergency services. All right, peeps. I'm hurting already. Yeah, we can't can this. A case out of lead. I will just cover with this conductive translucent TFT material or whatever it is. Yeah. All right, peeps. I need to go off. I'm really I love it that you're so engaged, but I need to go. Yeah. All right. I see you next week. I hope I'm good again. Thank you for joining. Oh, Cigaretta, you're too late. I need to go, unfortunately. I'm not feeling good. Bye bye. So, have a good night, peeps. I see you next week. Sorry it was a short stream. No, not I take ibuprofen. That works better for me. Somehow paracetamol never works for me. Bye bye. Good night, everyone.